I'll show you two ways of doing this question. So first of all, method one. Let's say we've got 4 children in the corners of the pool, and then we've got the coach, say here. Now, looking at this, we can see that if we consider 2 children on opposite corners, then the top right would walk this distance, and the bottom left would walk this distance. And this is half of the perimeter. And if we apply that to the other one as well, then we can see we've got this and this, which is also half the perimeter. So overall, all 4 children would walk the perimeter, which is just 10 plus 10 plus 25 plus 25, 70 meters. And therefore, the coach needs to walk 20 meters. Okay, because we're talking now about the scenario where only 3 of them walk. So say these 3, then they've walked 50 meters, but we know they walked 70 meters in total, and therefore, yeah, the coach walks 20 meters. Notice this actually rules out the coach standing along this line, because then it would definitely be less than 10 meters for either of these two, and more than 25 for these two. So we kind of showed that the coach actually has to stand along one of the lengths. And this would be one possibility. So, we could try and just check our solution now. Let's say the coach stands here. So this is 5, and then this is 20. So that would be this. That would be the one that's not walking, and then this person is walking 10 plus 5, so they're going to walk 15. I'm just going to write this down as a little sum, 15. And this person's going to walk anti-clockwise, so they're going to walk their 10, and then their other 20, 30. So you can see that these add to 50, and then we just got this extra 20. I'm going to show you a second approach to this question now, although I think there are flaws in it. So I'm going to set it up in the same sort of way. I still want to talk about it though, because aspects of it are okay. Right, I've got there, and I've got the coach here. So I'm going to call this distance x, and this distance will be 25 minus x, and this is obviously 10, 10, and 25. So I could add up all the distances that the children have to move. X plus 25 minus x plus 10 plus x plus, they walk around this way, 35 minus x. And what we see is that the x's actually cancel and that we're left with 70. So this is a very similar approach. It's just using out, like not realizing just by looking at it that a pair of them in opposite corners walk half the perimeter. It's kind of like doing it algebraically, and then you'd have to realize, oh, okay, yeah, that's what's happened. So it must be that because 3 of them have walked 50, then x is equal to 20. Okay, so actually that way of doing it is okay. So I didn't actually do it that way. What I did is I considered 3 of them. And here's the flaw really. How do I know which 3 are moving? So I said that these 3 are moving. And then I've got very similar to before, but I don't have the x in there. So I ended up with, well, let me do it. So 25 minus x plus 35 minus x plus 10 plus x is going to equal 50. So I set it equal to the 50 here, and that left me with 70 minus x equals 50 and x equals 20. And I went, yeah, 20, that's the answer, and I was done. But in my method, I think this is a problem. How do I know that it's this one that didn't move? I think I'd need to check out all the cases. Now, it turns out if you do check out all the cases, like what I mean is if this person moved, this person moved, this person moved, you get 20 each time. Is that obvious? I, 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 I don't, I think we need to actually check it just to be certain. So that's what I mean by a flaw. It's like it still works, but we have to, if we're being thorough, which you don't necessarily need to be in this competition, but sometimes it can lead to mistakes, especially because it's talking about the shortest distance. Now it's actually referring to the best path, not going around like the long way. Not like if you want to go to this person going around this way. That's what it means by the shortest path. But still, um, I think, yeah, I prefer the first method now. The other thing to say is if we do try and stick the coach on this side, then it would turn out that you get a negative value for x, um, or or a value of x that's less than um, I can't remember actually, but I remember like because obviously if the coach is walking to this person, it's from here, it's actually going to be more than 25 because they got the 25 length and they've got this distance here. So I think you end up with x equals -5. Um, basically get into complications if you put the coach here. So I've talked about this for a little while. This is definitely a good approach, just quite quick if you can spot it. This approach is good if you go with this method. If you go with what I did, then it's not as good. You have to check every single case. You have to think about whether the coach stands here or here, which when you do the first method, you just very quickly see that they can't possibly stand here because they have to walk 20. So, it's got to be like somewhere along here or here. All right. Anyway, that's quite a significant overview of this question. Answer is 20 meters.